have them right here.
What if black holes are ripping the universe apart? So if you think about ideas of black holes, in theory, I guess rotating black holes have layers, where you could be inside a black hole but not actually be inside the black hole. And it's I guess the difference in the equations between a stagnant hole and one that is rotating, and it is obviously rotating. I guess the math behind it, but I don't really understand any of that. It's just the idea that the universe is expanding in all directions. And what they say about light falling into a black hole as being in a black hole and then observing light falling into a black hole, you'll observe the light just normally. And as you fall into the black hole, the light will get stretched out more and more and more, and you will move through time slower and slower and slower. And when the light hits you, it's just, twofold. If you get to the point where you're accelerating faster than light, but you're never really going to get there, according to theories of I don't know, according to astrophysics, it's the idea that you could observe light inside a black hole, and what's outside a black hole cannot observe light coming outside of it because the light never reaches outside. And the gravitational force of the black hole stretches the light to infinity. But that's the whole thing. The idea is, can you stretch light without actually making space? Without actually moving away from the source? But it's an accelerating thing, so it's not distance, in which case it maintains its frequency not because of the distance, because of the acceleration. I wonder how much this has been tested. I don't know, I have a stupid idea where it's the distance between the two objects that matters, or the added distance, in which case energy does not transfer from the distance object. Like, let's say it was the sun. It takes 8 seconds for light from the sun to reach you. That energy gets instantaneously transferred the second it reaches us. And that photon hits us, and then it stops being in the past at the sun and starts being in the present where we are. And that's how that works. I was just thinking, wouldn't you just add the distance? Like, if it hasn't reached anything yet, let's say that light, the little beam of light, is running away from whatever it's running away from. And energy doesn't transfer until it hits something. Until that point in time, it's just interacting with itself, and it's still in the past at whatever distant object it was at. I'm wondering if the distance itself matters. I need to see the equations. I need to see the numbers. It's like if I added distance before the photon hit anything, would the frequency lessen alone? In which case, it'd be like if you were not moving in comparison to that far distant object, and then you decided to throw the light beam, and then you decided to move away. Would it redshift? And they say it doesn't. As compared to you having to start moving before the redshift happens. Or the blue shift, depending on whether or not you're running towards it or going away from it. Like, if energy instantaneously transfers from said distant object to whatever object it ends up running into, would the distance itself actually be just as relevant, or perhaps more relevant in the fact that it's accelerating away from each other, rather than the fact that it's accelerating away from you. As in, this much distance was added before the photon itself ran into anything, as being the most important factor, in which case I'd have to actually conduct an experiment, and I don't know how to do that. It's also the idea that the black hole is ripping space apart. So not only is it a black hole, but it's creating space between objects, as in the most distant objects are being ripped further apart than the closest ones. As in, if you think about it, when you fall into a black hole, and it would make sense that there would be a lot of redshift, as in we are actually somewhere in like the event horizon of a black hole, or perhaps all galaxies are, or many galaxies are. And then it's like the gravitational force overcomes the fact that it's ripping space apart at some point in time. But it's the idea you're getting further and further away from things that that are already very far away, and closer to things that are closer as time goes on. So you're always falling into a black hole, right? So technically we are falling into a black hole right now. In the center of the Milky Way galaxy, we are falling into a black hole. What if the hole itself was falling into a hole? Into a three-dimensional hole? What if it was a three-dimensional hole? What if it was an actual three-dimensional hole that's moving away from that? You're falling into something in 3 dimensions. So it would be like a hole. Like a hole in 1 dimension is linear because you fall downwards, right? But what if falling wasn't linear? What if you could fall in 3 dimensions? In which case, that's what the hole would be. It would be something that's falling. And you'd be falling into a hole. And you keep falling into the hole. But the hole is falling into the hole. As everything around the hole is falling into the hole. All the time. Away from everything else. That would be simpler. That would be easier. That would make sense. Rather than I have no idea what they're saying anymore. I just forgot what they were saying. I just completely forgot what they're saying. I need to talk to somebody. And that gravitational pull, at some point in time, if it gets too far away from you, you fall away from it. So it's a hole in 3 dimensions, is what it is, falling away from everything else in 3 dimensions.